ये सारा पढ़ दिया एक बड़ा था मेरी क्लास में सर आज 1 घंटा इजाफी भी लेना है
आज का हमारा जो टॉपिक है वो मोनोटोनिक फंक्शन इन फर्स्ट डेरिवेटिव।
आगे आगे
The idea of this base lecture will be about somewhat related to 2.9 we have done at the level. So you have heard that if the derivative of a function is positive in a certain interval, then what about the function behavior on the interval that will be on closed interval, and if the derivative is negative, then f is again this result is to be discussed as a third problem. Previously we have discussed two problems in the theorem, which were also well known facts about the constant function, and one of the problems was that if the derivative of the function throughout an open interval, then we have learned that f of x will be constant throughout the interval. Though it was well known fact, but we because the set is based on the h on the b value, and it was discussed as first value. And secondly, we have discussed that if the derivative of two functions is same on an interval, then the functions will be related. In this case, or and this result is to be further used in the process of integration or integration. So these are the first two problems of Mean-Value theorem. Now we are to discuss the third problem of Mean-Value theorem, which is that if the first derivative of function is positive on an interval, then the function will be increasing on closed interval. Again, discuss that we are saying that the derivative is positive on the open interval, but the statement about increasing or decreasing here is on the closed interval. We will also put this fact based on the. So again, firstly, what are the monotonic? You are seeing a definition that a function that is either increasing or decreasing is said to be monotonic. A function which is either increasing or decreasing is termed as monotonic. So increasing and decreasing functions are termed as monotonic. So what is the third problem in Mean-Value theorem? Again, the conditions are the same hypothesis for the Mean-Value theorem, that f is continuous of closed interval AB and differentiable on the interior of the interval. derivative is positive in the interior. Since we always consider the derivative of the function on the interior form. Since the derivative is not required at the end point, so usually the smoothness doesn't exist at the end point of the domain. So smoothness is just required for the interior point. So if derivative is positive at each point of the interior, then f will be below the closed interval, and if derivative is negative at each point of the interior, then the function is decreasing between the closed interval. So we consider any two points in the closed interval. Here is that we are considering any two points from the closed interval, not in the open interval. And as will be the case that since the 2 points will be some real numbers, so according to triquadratic property, either x1 will be less than x2 equal to x2 or greater than x2. Definitely we will be considering different points. So either x1 will be less than x2 or x1 will be greater than x2. So when you consider x1 as a number less than x2, so we will get an interval from x1 to x2. Now since x1 to x2 will be a subset of the interval a to b, and the hypothesis of the value theorem is valid for this greater interval, so it will be valid for the subset as well, because these are any two points within the interval. So this interval will be a subset of this interval. Therefore, all the hypotheses which are true for this interval will also hold for the subinterval. So f will be continuous to this interval and differentiable on its interior. Therefore, by mean value theorem, there must exist at least one point in the interior of this interval. In the interior of this interval, and since this interval lies in the interior of this, this implies that C also belongs to open interval. Such that f minus c is equal to f of x2 minus f of x1 divided by x2 minus x2. Here the straight line is brother. x2 minus x2. F of x minus f of x1 is equal to derivative of c x2 minus x1. Now since x1 is less than x2, so x2 minus x1 will be positive. So the sign of f of x2 minus f of x1 will depend on the sign of derivative of the function at c. Derivative of the function at c. So
चैट जीपीटी मेरी वाले चैट जीपीटी ओपन कर लेते हैं चैट जीपीटी
f of x2 minus f of x is equal to f minus x minus x1. So if f prime is positive, then this will be positive as well, and therefore f of x2 will be greater than f of x1. F of x2 will be greater than f of x1. And what about the behavior of the function in this case? Since x1 was less than x2, this has led to the implication that f of x1 is less than f of x2. So the function will be increasing or decreasing. If x1 is less than x2 and the value of the function is retained in the same way, that is f of x1 is also less than f of x2, then function is increasing or decreasing? Function is increasing. So if f is positive, then the function will be increasing on the closed interval. How will you write this statement to conclude the two? You will say that since x1 and x2 are two arbitrary points of the interval, the function, therefore the function is increasing for any two distinct points of the interval, that is the function is increasing throughout the interval. Therefore function is increasing. So for positive, derivative of the function will be increasing, but if the function is negative, in fact we have proved this theorem. Did we prove this? So if derivative is negative, then what will happen? If the derivative is negative, then in that case we will get less than 0. So in this case it will be less than 0, and f of x2 will be less than f of x1, and here f of x1 will be greater than f of x2, and the inequality will be reverting. Therefore the function will be decreasing. So if the derivative is positive, function is increasing of the secant term, and if the derivative is negative, the function is decreasing. Now we are to consider the same scenario which you have done at inter level in 2.9, where you have determined the intervals of which the function was either increasing or decreasing, and based on the increasing and decreasing behavior of the function, we are to determine the local extreme value. You have, if you remember, you have discussed that if the derivative changes from negative to positive, negative to positive at a point, say interior point, we are discussing about the interior point belonging to the domain of the function. Then what about C? F will be having a local minimum at C. And if the sign of f prime changes from positive to negative, then the function has a local maximum as well. This was the first derivative test. So we are going to discuss the first derivative test. So in order to discuss the first derivative test, if you observe this paragraph, it has discussed that we will be given provided with the domain of the function. So firstly we have to partition the domain based on the critical point. Firstly, what we have to do is that we will find the critical point of the function. What are the critical points? Critical points are the points where the derivative is either 0 or undefined. Say we have two critical points, A and B. So suppose that then what about the behavior of the function of the operator? Behavior of the derivative of the operator. Since the derivative of the function is either 0 or undefined at A or B, but it will be defined within the interval. That is, the derivative will be defined throughout the operator relation. That is, it will be definitely continuous throughout the interval. Have you got this point? So we are saying that since we are considering A and B as two critical points of the domain of the function, that is, these are the points where the derivative is either 0 or undefined. So it will be the case that within the interior of these points, within the interior of the critical points, the f prime will be continuous throughout the interior, because there is no point where it is either 0 or undefined. That is, it is defined throughout the domain, therefore it will be continuous throughout the interior open interval. Therefore, since its behavior will be uniform throughout the interior, and it is to be 0 at A or B. It is to be 0 at A or B. So it will be either positive or negative throughout the interior. since it is to be change its behavior at b. So if it is 0 at a equal to 0 and it is positive greater than or value greater than a, then it will remain positive up till b. So throughout the integral domain, either the derivative will be positive or negative. It cannot change its sign because it will not cross the x-axis within the integral. Since it is to cross the x-axis at b. Have you got this point? Since these are critical points, so the derivative will be either positive or negative throughout it. So if we are to check the sign of the derivative, we may choose either of the point from the interior and check the sign of f prime. So if f prime is positive, then it will be positive throughout the interior. So we will get the behavior of the function that if it is positive, then function will be increasing throughout this interval. And if it is negative, then it will be negative throughout the interval. That is, the function will be decreasing throughout the interval. For example, we right. We are considering two interval, so there will be no point where the function is undefined. The only critical points are the points where the derivative is equal to. You can observe that the points are minus 2. Points are minus 2. So the domain will be split based on critical points from minus infinity to minus 2, from minus 2 to 2, and 2 to infinity. So these will be the sub-intervals. This will be the division of the interval based on the critical point. So what we have discussed that throughout the interval, the sign of the derivative will remain the same. It will change on the critical point or after the critical point. At the critical point, it will be exactly 0, and after the next critical point, it will remain the same. Either it will be positive or negative. So if function is positive or negative in this interval, then it will remain positive or negative. Like if we are to check the sign of the derivative of the function, we may choose either of the points. Say for our convenience, we use a simple integral form, x equal to 1. If you check the sign of f prime of minus, this is prime of minus 3. Minus 3 plus 2. Have you got this? F prime of x is 3 x plus 2 and x minus 2. What is the value of the derivative? Minus 3. 3 minus 1 and minus 5. It will be positive. That is, the function is increasing on this. Be conscious about checking the value of the derivative, not of the function. You are to check the value of the derivative. Since based on the third trolley, we have a result that if the derivative is positive, then the function is. If the derivative is negative, then the function is. So we have to check the value of the derivative. So throughout this interval, the value of the function is increasing. And we are to write that the function is increasing on minus infinity to minus 2 and close from minus 2. We have to check the value of the derivative within the interior. But when we are to write that the function is either increasing or decreasing on the interval, we have to close the interval from that side. That means we have to include minus 2 as well. Since we have discussed this case based on the third one. Also, what about minus 2 to 3 2? What will be a convenient point to check the sign of f prime? You may check x is equal to 0. So what about f prime of 0? F prime of 0? Negative. It is negative. Since it will be 3 2 minus 2. So it will be 6 into minus 2. So function will be decreasing. Function will be decreasing on, how to write it? Function is decreasing on minus 2 to close. Function is decreasing on the close interval. And what about 2 to infinity? You may choose So if we choose 3, what will you get? 3, 5, 1. It will be 1. Function will be increasing on the interval 2 to close. Open from the now we move on to the criteria of first derivative test for local experiment. What is the first criteria for first derivative test? If you observe the behavior of the derivative about a critical point, suppose you check the behavior of the function at C3, derivative, behavior of the derivative. Then what is the derivative? Derivative is basically what does the derivative represent at point? Derivative represents the slope of the tangent to the other side. If you observe the tangents on the left of C3, they are somewhat in this way. Are you observing that? It will be since it will be in this form, tangents will be like this. Are you getting this? So tangents will be. What about the slope of the tangent? Slope will be negative or positive? Since it is not up to down, the tangent, the value of this slope will be negative. So immediately to the left of a value where a function has local minimum value, the derivative is always negative. Immediately to the left of a local extreme of the local minimum value, the value of the derivative is negative. But if you observe immediately to its right, then these tangents are like this, going up. Therefore, since x2 minus x1 is always positive, the sign depends on the difference of y2 minus 1. When this tangent is like this, then y2 will be greater than y1. If that means y2 minus y1 will also be positive, and if that means the slope will be positive, that is the derivative positive. So immediately to the right, where a function has local minimum value, the derivative will be positive. And for a local maximum value, it will reverse. Then it will be like this, only in the left side and for it means that at a local value, where the function has a local maximum value, the derivative is positive immediately to the left and negative immediately to the right. So this is what we have discussed in this paragraph, that at points, if you observe it, at points where f has minimum value, derivative is less than 0 immediately to the left, and the derivative is positive immediately to the right. And as you are observing that the graph is moving down, that is immediately to the left the function is decreasing, and immediately to the right function is increasing. And for this, immediately to the left function is increasing, and immediately to the right function is decreasing. And he is giving the same that the function is decreasing on the left to the minimum value, and it is increasing on its right. And at a point where the function has a maximum value, derivative is positive to the left and negative to the right. That is, it is increasing on the left with maximum value and decreasing on its right. But in both cases, it is being observed that at a local extreme value, the sign of f prime is changed. At both values, either in the local minimum value, either in the local maximum value, the sign of f prime changes either from negative to positive or positive to negative. That is, in both cases, the sign of f prime is changed. So if at a critical point, the extreme value exists, then it will be the case that the sign of f prime will change. It is not necessary that at a critical point the function must possess a local extreme value. It may or may not have a local extreme value at a critical point. But if it does possess a local extreme value, then it must be the case that the sign of f prime must change from positive to negative or negative to positive. That is, the sign of f prime must change at a critical point in order to have a local minimum or local maximum. criteria or in terms of a theorem, first derivative test for local is that suppose that C is critical form of a continuous function f, definitely the function we are to consider will be continuous function. So if C is a critical point of continuous function and f is differentiable at every point in some open interval containing C except possibly at C itself. Except possibly at C itself. Why do we state such type of statement except possibly C itself? Because C will be a critical point. And what about the behavior of f prime at a critical point? Either it will be no or so it may be possible that the derivative will not be defined at that point. Therefore, we are stating that except possibly at C itself. That it might be possible that the derivative does not exist at that point. That is, since it is to be a critical point, therefore it might be possible that f prime is not defined. Moving across this in terms from left to right. Since if C is any critical point where either derivative is 0 or not defined, we are to consider its neighborhood. We need to consider the neighborhood of that point. C minus delta C plus delta. Or in other words, we may consider an open interval AB containing C. Open interval containing C. Centered at C. So at that interval, we may say that from C minus delta to C, if f prime is negative, but if from C to C plus delta, the derivative is positive, then C will be a function will be having a local minimum or maximum. Local minimum derivative. That derivative is taking sign from negative to positive. Or we can state it in this form: A to C and C to B in that. So the proof will be constructed based on that concept. This is the concept of the neighborhood. If you remember the concept of neighborhood, we have defined it in this way. This is considered as the neighborhood of C. We have defined in 1.1 as the absolute value of x minus C is less than delta as the delta is the rule of C. So if f prime changes sign from negative to positive at C, then f is local minimum. Now we also do this part 1. Since the sign of f prime changes from negative to positive at C, sign of f prime changes from negative to positive at C. So sign of f prime changes from negative to positive. So there is stated that there are numbers A and B. There are numbers A and B of the form that A will be some number of C minus delta form, B will be some number of C plus delta form, such that there will be an interval from A to C minus delta to C, where derivative is there. Or in other words, we can also say that there is also an interval from C to C plus delta on its side. This is for the interval which is left of the point where the function is to attain either a local minimum or local maximum. So we can also consider it at some point B, and here the function is to be positive. If there exist numbers A and B such that A is less than C is less than B, can we write it since C in the interior of this number? Or we can say that C minus delta is less than C is less than C plus delta. Do you remember this? C minus delta is less than delta. If only minus delta is less than x minus C is less than delta. If only C minus delta is less than x is less than. So you may consider it as So for any x in this interval, what is the relation of x with c?
Less than.
X is less than c. And since f9 is less than c, so f will be decreasing or increasing? Decreasing. So what about the sign of f? It will be reverted because function is decreasing. And what about the relation between c and x in that case? C will be less. C is the smallest number here. For any x within that interval, x will be greater than c. And what about f of c and f of x in that case? Since f is positive, f of x is positive, x will be increasing, thereby retaining the integral. If we combine both of these relations, in both cases, f in both cases for all x belonging to open interval a b, f of c and f of x are to be related in this way. Have you got this? Now we have also included equality. Listen,
Because C is about.
we are now included c as well.
C is
So f of c is less than equal to f of x for every point in the interior of this interval. So what about the value of c? What about the value of the function at c? It will be equal to a local minimum value. It is a local minimum value. Since in the neighborhood of c, the value of the function is in the neighborhood of c, the value of the function at every point is greater than its value at c. Therefore, f becomes the local minimum. If you remind about the definition of local minimum and local maximum, function has local minimum value at point c if f of c is less than equal to f of x in the neighborhood. This was for the local extreme value, local minimum value. For absolute minimum value, what do we consider? The function has an absolute minimum value at c if it is valid for whole domain. If it is valid for the whole domain. But if it we are considering just for the neighborhood of c, just for some small neighborhood of c, it will be taken in the local sense. Have you got this?
Yes.
Similarly, you can prove it for 2. You may take it as your assignment. You need to do the same for local maximum values. With your assignment that you may do this, produce the same proof for part 2. You are to produce the same proof as an assignment for the second case, that if f prime changes sign from positive to negative, then f has local maximum at c. So it will be just because that instead of less, it will be positive. If instead of greater, it will be less. It will be increasing here, it will be reversed. So in that case, f of c will be greater than c equal to f of x. So f of c will become the local maximum. Now, using the first derivative test, we are to determine the local extreme values. Find the critical parts. First is find. Now we are in 4.1 to 4.2. We have in fact in 4.1 we have discussed the local extreme value of the function which was continuous and finite kilometer. In 4.1 we have discussed the local and absolute extreme values of the function which was continuous and finite kilometer. Now we are considering more general question where the function is still continuous, but now the domain has extended to infinite, has extended to infinite domain as well. Previously it was restricted to finite kilometer. Now here is the case where the domain is not necessarily finite kilometer. Like here for the first question we observe that the function is x power 1 by 3 times x minus 1. So what about the domain of this function? What will be the domain of this function? Complete set. X minus 4 is again a polynomial, linear polynomial, degree 1 polynomial, and x power 1 by cube root of real number. Cube root. What about cube roots? In case of cube root, one root will be necessarily real number. So So in that case, we will get the root. If we are considering cube root of minus 1, what will be the cube root of minus 1? It will be minus 1. Definitely, the cube root is the same number in case of real number. It may be possible that all three roots are real, but if they are to be complex, they could be at most two. One will be again real. So the domain is complete set of real numbers. So there are no endpoints to consider. Are there any endpoints? No endpoints. Since we are also always bounded to consider the value of the function at the endpoint. So here there are no endpoints. We will not be considering the value of the function at the endpoint. Since there are no endpoints. Now only the extreme values may occur at the points which are the critical points. So we are considering just the critical points. So find the derivative. What are the critical points? The points where the derivatives are 0 undefined. So there are two critical points. One is the point where the derivative is 0, which is x equal to 1, and second where the derivative is undefined, which is x equal to 0. So we have two critical points, x equal to 0 and 5. We will divide the domain based on these two critical points as minus infinity to how to take domain based on these two critical points. It will be divided into minus infinity to 0, 0 to 1 and 1 to infinity. So we may choose either of the points in the interior of this interval, this one and this one. We may choose minus 1 by 2, 0.5, 2. So we will check the sign of A. What is the derivative? X minus 1, x power 2. So here if we are at minus 1, what is the derivative? 4 times x minus 1 and 3 times x power 2. May consider it as 2 scale whole power 1. What about the value of the derivative? Value of the derivative at minus 1. Value of the derivative at minus 1. It will be minus 1, minus 1, minus 2, minus 1 square. It will be positive. So it will be negative. It will be negative. So on this interval function is decreasing. What about this one? It is a positive number?
Yes.
But positive minus 1. It will be negative. Scale positive. And how are the value will be? Again. Function is again decreasing. What about the value 2? 2 will be greater. Now we have to consider the value greater than 1. For values greater than 1, x minus 1 will be positive. It is here, it is positive. So it will be. Now we are to determine the behavior of the function at the critical point. Function may either have a local minimum or maximum at either of the critical points 0 and 1. There is no end point. So if the function possesses the extreme values, they may only occur at either x equal to 0 or 1. The criteria will remain the same, that if the extreme values of the function occur, they may occur either at the end points or critical points. Either at the end points or the critical points, same criteria which we have discussed based on theorem 1 and theorem 2. We are using theorem 2 in that case that the extreme values, if they exist, always occur at either the critical points or end points. There are no end points in that case. Only we have the critical points, so function will attain either of these extreme values at either of these points. So at x is equal to 0, the derivative doesn't change the sign. It remains negative on both of its sides. That is, it is decreasing throughout any open interval containing x is equal to 0. That is, f prime doesn't possess any local extreme value at the critical point x is equal to 0. Reason? Have you got the point? That f prime doesn't change sign at x is equal to 0. It is negative to the left as well as to the right of x is equal to 0. Therefore, there is no local extreme value of the function at x is equal to 0. Whereas if we consider consider x equal to 1, the derivative changes sign from negative to positive. What about the extreme value of the function at x equal to 1? It will be having local minimum as well. It will be having local minimum value at x equal to 1. So, what is that local minimum value? Now, in order to determine the local minimum value, we will determine the value of the function at x. What is f of 1? You can determine that f of 1 is consider it. 1 minus 2. 1 minus 2. क्या आती है? minus 3 आती है? So, the local minimum value of function is minus. In question you are also asked to find the absolute extreme value. Also, to find absolute extreme value. We have discussed that when there is a local minimum value, there is an absolute. So, it will be an absolute minimum. Reason? Because the function is decreasing throughout the interval minus infinity to 1 and it is increasing on 1 to infinity. So, at function will be like this. It is decreasing from minus infinity to this one. What is this? 1. And at that point, the value of the function is f of 1. f1 is 1. And it is increasing throughout the interval. Therefore, this value will also be the absolute value. To its left, from minus infinity to that point, and it is increasing to its right throughout the increase. Therefore, this derivative minus 3 is also the absolute because there is epsilon on its domain. But it doesn't have any absolute or local. Example 3, find the critical points of this. Identify local intervals of the function is increasing and those on which it is decreasing. Find the function local and absolute extreme. Now again, x square minus 3 is the function product of the functions x square minus 3 and exponential of x. What is the domain of x square minus 1? Complete selection of is quadratic polynomial of degree 2. And what is the domain of exponential of x? Algebra. Again, if we are to combine two functions in terms of product, then their domain will be according to 1.2. What have we discussed about the domain of two functions to be combined based on their algebraic combinations? Addition, subtraction, multiplication. Common points. Common points will be complete set of values. Since both functions are dependent on complete set of values. So domain is complete set of values. Again, we do not have any endpoint. So extreme value will occur only at the points where the function is either where the derivative of the function is either 0 or undefined. That is, the function will attain extreme value only at critical values. So we need to find critical points. Therefore, we have to take the derivative of the function. So derivative of the function after simplifying we get x square plus 2x minus 2x plus 3. So is derivative undefined anywhere? X square plus 2x minus 3 exponential. The derivative is defined throughout the set of variables. So complete set of variables. There is no point where the derivative is done. Therefore, the only points where the derivative is where the critical points exist are the points where critical points are the points where the derivative is 0. So x square plus 2x minus 3 into exponential of x is equal to 0. Can exponential of function be 0? Elsewhere for any real number? Exponential function is 0. Since the range of the exponential function is 0 to 0, it should be open. Exponential function is never 0. It means that for the product to be 0, one of the numbers should be 0. You are aware of the fact that for the product to be 0, either should be 0. Either should be 0 means inclusive of either a 0 or b 0. are the points minus b. We are making x square plus bx minus x minus b into 0. X plus b minus 1 x plus b. So the points are 1 and minus 1 and minus. So the domain can be split based on the critical points minus infinity minus b minus 3 1 and 1 2. So we will check x is equal to minus 4 0 and 2. F what is f prime of minus 4? F prime of 0 and f prime of 2. In fact, you can check the sign of derivative. Derivative is positive for x into minus 4. For either of the points, x into minus 5 minus 6 any point. Derivative will be positive, it will be negative in this case, and again it will be positive. So, if the function is positive, then the derivative is positive, then the function is increasing on this interval. If it is negative, then derivative is decreasing, then the function is decreasing on this interval, and again, since it is positive, the function is increasing. Now, the sign of f prime changes from positive to negative. Therefore, the function has local maximum at this point, and since the sign of f prime changes from negative to positive, x is equal to 2, therefore the function has a local minimum. And these local minimum and maximum will also be x has to be minus. So on same line, we will practice some of the questions. Absolute value of x greater than 0. There is no absolute maximum value. क्या हो जाएगी इस बार? ग्राफिकल लीजिए चेक करेगा हम। क्यों जी? Absolute maximum क्यों नहीं? और absolute minimum क्यों? Why do we have an absolute minimum and why not an absolute? Function is decreasing, increasing on this interval. If you observe from minus infinity to minus infinity to minus infinity, it is increasing. From minus 3 to 1 it is decreasing, and again from 1 to infinity it is increasing. Have you got this point? From minus infinity to minus 3 it is increasing. But from minus 3 to minus 1 it was decreasing, and then it was again increasing. It was only decreasing in this interval. It was only decreasing in this interval. Neither of this or this, the function is decreasing. That is, it is increasing on all other intervals other than this. Therefore, the minimum value will be definitely, if it is a local minimum value at x is equal to 1, then it will be also absolute minimum. Since function will not decrease again, it will be increasing throughout, either to the left or to the right. Since the function is increasing both to the left and to the right of x is equal to 1, therefore the x is equal to 1 is also an absolute minimum as well as local minimum. See, this local minimum will also be an absolute minimum. Is it clear? But if you consider that the function was increasing in this interval as well as this interval, so x is equal to minus 3 will not be the absolute maximum. Reason, the function continues to increase in this interval, and the value is rising indefinitely up to h at least. So the function doesn't have any absolute maximum. The value is the local maximum value is the local maximum, is not absolute maximum. Now you may be confused about our statement that if a function has a local minimum, then it will definitely possess an absolute maximum. Absolute minimum. If a function has a local maximum, it will definitely possess a absolute maximum. Was in the case of finite closed interval. Was in the case of finite closed interval where extreme value is known. Here it is the case where we do not have endpoints. Where we do not have endpoints. And the value continues to rise based on endpoints. When the function is closed based on the endpoints, then it is always the case that local extreme values give rise to absolute extreme values. That is, if a function has a single local minimum or local maximum value, then the function will definitely possess absolute maximum and absolute minimum based on the existence of endpoints. When there are no endpoints, then this result doesn't hold in case when there are no endpoints. This result is based on the existence of endpoints. Since in the case when the function doesn't have endpoints, the function may continue to rise or fall. If it is decreasing, it may continue to decrease to its end, or if it is increasing, it may rise to its end, right? Like it is happening in case from from 1 to infinity. Therefore, in that case, function doesn't have an absolute maximum. Have you got this point? ये बात समझाइए कि नहीं? ठीक है? वो जो local minimum और local maximum की base पे absolute maximum और absolute minimum की existence की बात थी, it was based on endpoints. Finite closed interval case. ठीक है? Since it is not a finite closed interval, therefore that result doesn't extend in the case when the domain is unbounded. So you may personal practice some of the questions from the exercise as well. अभी कौन-कौन से क्वेश्चन करना चाहिए? If you consider question of channel, now some of the students when they are doing questions of this sort, what are the critical points on what of an interval and increasing and decreasing? First in the question you have to just determine the critical points. Secondly, on what interval that is increasing and decreasing at what points, if any does that has local minimum maximum. Here you are not provided with the function but the derivative. You are provided with the derivative. Based on the derivative you are considering the values. So in fact these questions are simple questions from 1 to 14 questions. The questions, if the question was just to get the idea, if the question was of this form, here since we are provided with the derivative, so what are the critical points in this case? X equal to 0 and x equal to 1 where the derivative exists. That is where the derivative is 0 and x is equal to minus 2 as also equal because the derivative is nothing. But instead of derivative, if the function was to be defined in this form, then what will be the derivative? Will you calculate the derivative? The derivative will be of the form say x plus 2 whole square and 2x. And what will be the next one? X 1. X square times x plus 2. And what will be the next one? X plus 2. X plus 2. What derivative are taken? और उसी तरह x square. So we will get some relation of this type. That should be simplified to get some idea. What I want to say is that a big difference will be in the case 2x x minus 1 by x plus 2 x square minus x plus 2x minus 2x square plus x minus 2 x square. We are multiplying 2x as well. We need to multiply by 2x as well. 2x cubed plus 2x square minus 4x. So what amount is? X cubed plus 2x square minus x cubed minus plus x plus 2. So the value of the derivative will be 2x cubed minus x cubed. X cubed. And what about 3x cubed plus 3x square and minus 4x square 2x minus 4x x plus 3 minus 2x. So can we add this? And we have vector. Also assess this point in previous sessions about multiplications of this formula. Like 35. You may practice 35. But what about 36? What is the domain of the function in 36? 35 and 36 are different. The domain of the function in 36 is the fixed domain. Is the domain of the function a fixed real or a hard? A fixed real. Yes. Function of 36 is different from 35. Function is not defined as sum of the complex numbers, but is defined for every real because of the scale, because of the x scale. But 35 is not defined for x scale. X is not defined. Here I have specified x not equal to, but still some sort which can be taken as a critical point. So it will not be critical point will be a point which is from the domain of the function must be defined. If function is defined, then we can check about the value of the function. If the function is not defined, how will we check about the value? Well, it will not be possible to set the value. And also, the critical point is what? Is the interior of the domain. So it is not from the domain. So you may practice 35. For assignment 2, 35, 36. Some of the questions involving logarithmic functions as well. You may practice 45. What is the domain of log of x? Log of x the domain क्या होगी? Log and exponential function are exponential function domain is complete set of real numbers, whereas its range is 0 to infinity. So range becomes domain in case of log. So log is defined only for positive real numbers, but its range is complete set of real numbers. So we have to consider of the domain in case of 45. So what about domain in case of 45? 0 to infinity. Do we have an endpoint in this case? No. Again, no endpoint. So when you are asked to judge the absolute extreme value of every quantity about the behavior of the function, out of local maximum or local minimum, the function may have an absolute maximum or absolute minimum out of local minimum or local maximum. Or it might be possible that it may have no absolute minimum and no absolute maximum. Instead, it may possess both local minimum and local maximum, but it may not have either of the absolute maximum. You got this point? ये भी हो गई 35 45 और कौन सा पसंद है चल ना हायर डिग्री में देख रहे 29 में what's 29 options in assignment what's 34 2, 3, 4, 5. One more.
67. 67.
One pound of 27.
बढ़िया ठीक है
39.
काफ़ी है सर रहने दें
आप पहले पसंद
दैट्स इनफ ब्रो
फर्स्ट में से आपने जो प्रैक्टिस करने हैं स्टार्टिंग में इसमें कुछ क्लोज बाउंड आ गई है फाइनाइट क्लोज इंटरवल 0 to 5 अब इसमें एब्सोल्यूट एक्सट्रीम वैल्यू ठीक है कंटीन्यूअस फंक्शन दोनों एक्सट्रीम वैल्यू है एब्सोल्यूट लोकल वैल्यू नहीं एब्सोल्यूट नहीं तो 13 14 में से एक करें 13 कर लें 7 पे कर लेते हैं 7 पे प्रैक्टिस में किसी पे और 5
14
ये हो गया
थोड़े लगने के बाद ही खत्म हो जाएंगे 10 मिनट में सारे क्वेश्चन करेंगे 10 मिनट में